Hi, welcome to part 2 of our Killer Sudoku series. Part 1 we covered the rules of Killer Sudoku, how it differs from the regular Sudoku puzzle, and we looked at a couple of techniques to get a foothold in a puzzle where you start with no apparent clue numbers. So again, we're looking at this level 1 puzzle, which you can download for free if you want to follow along. There's a link in the description. It's part of our Killer Sudoku challenge pack. And this time we're going to look at what we call the 45 rule. So we know that in Killer Sudoku, like in regular Sudoku, we're trying to fill each row, column and block with the digits from 1 to 9. If you add up the digits from 1 to 9, you get 45. This is useful information to know because it enables us to eliminate or calculate the contents of certain cells through arithmetic. Now, there's a few techniques we can use that are based on this rule of 45 or the 45 rule. And the simplest of those is what we call innies and outies, which are nothing to do with severance, brilliant though it is. Let's have a look at an example of a very simple single cell innie. Now for this example, I'm going to concentrate on this block here, this 3x3 block. If we look in the block, we can see that it contains a number of cages that are fully contained within the block. I don't cross into any other block. Also, in addition to these 4 fully contained cages, this 17 cage here intrudes into the block. It starts here outside the block and it intrudes in like that. That means if we add up the target sum numbers of this block, which is the 17, 12, the 6 and the 7 down there, then we get a total of 42. In other words, all of these cages that are fully contained within this block add up to a total of 42. We know that the total of the block must eventually add up to 45 because that's what you get when you add 1 to 9. So from that we can deduce that the one cell that is not part of those cages, the innie, must be 3. It must contain the 3 because that's the only way we can get everything to add up to 45. We don't have to look at any candidate numbers or any limited sums. We could determine the contents of that cell just by using the 45 rule on an innie. Now we use the 45 rule here on a block. It works as well on rows and columns because they also add up to 9. But we can go further than that. We can use multiple rows, multiple columns or multiple blocks. And I'm going to show you an example of that. If we look at these 2 blocks down here, we've got a similar situation going on. We've got all of these cages that are fully contained within the 2 blocks. This cage crosses the block border, but it's still contained within this block of 2 blocks. And in fact, everything is contained except for this 11 cage here, which is another innie because that's penetrating into the block of 2. So we can do the same thing. We can add up all these target sums. So we've got a couple of 11s, 15s, 17, 10, 6, 7 and a 5 down here. And if we add all of those together, we end up with 82. We're using the rule of 45, but we've got 2 blocks, so we need to double our 45. So our target sum for the combined 2 blocks is 90 because it's double 2 times 45. We got 82 by adding together the contents of all the cages that are fully contained, which is these cages here. So we can work out that this cell must contain an 8 to bring our total up to 90. So again, we used an innie combining 2 blocks, but we didn't have to do any limited sum calculations or anything like that. We can go a bit further with this one as well because this cage here, this 11 cage, has only got 2 cells. We know this one is an 8. Clearly, we have to put a 3 in here to reach our target. So this innie has solved 2 cells for us. So that's an innie. Let's have a look at an outie. It's pretty much the same thing but in reverse. And to look at one outie on this particular grid, we're going to look at 4 blocks combined. These 4 blocks here. The outie we're looking at is this 12 cage here, which starts within our 4 block range and extends out. So then I'll just draw that one more time for you. You can see that all of the cages except that 12 cage are fully contained within this set of 4 blocks. So again, we're adding up all the digits for all the cages in these 4 blocks, including the 12, because the 12 originates within our 4 blocks. And I'm not going to go through all the numbers, but if we add them all up, we get to a sum of 183. How does that help? Well, because we're using 4 blocks, we can multiply 45 by 4, which gives us 180. We've got 183, which means that because there's 12 cage here is extending out of our block, this cage here contains the overflow, so this must be 3. By putting 3 in there, we're effectively removing it from our sum of 183, and that's how we get to 180. And we can do exactly the same thing because this cage is just a 2-cell cage and we've sold one of the cells. We can work out the other cell is obviously a 9. We could have worked that out, by the way, as an innie, because it's also a single cell innie in one block, which would have been easier than adding up these 4 blocks, but I was just trying to demonstrate how an outie works for you. So that's how we do single cell or simple innies and outies, but we can go further than that. We can look at multiple innies and multiple outies. I'm going to look at an example down here. On this block, we've got 3 cages that are fully contained within the block, and then we have 2 cages that extend beyond it, so it's a double outie. Now, how much these double innies or multiple innies and outies are of use depends very much on the configuration, and we may need to combine them with limited sums and so on. All we're going to do here is add up to some target numbers of all the cages that originate within our block, and that gives us a total of 51 in this case. So we know that we're 6 over our target of 45. So what that's telling us is that the 2 outie cells between them add up to 6. And what we can do is we can kind of draw in the new cage on here, call it a pseudo cage, and it's as if we've added a new 6 cage to the puzzle. As I say, how useful that is depends on the configuration of the puzzle. Here we can look at limited sums. How can we add up 2 cells to 6? Well, we can write in some candidate numbers. We could do 1, 5, or it could be a 2 and 4, or it could be 4 there and 2 here, or it could be 5 here and 1 here. We can reduce this further because this is a 5 cage and looking for 5. We're looking for a total of 5 with 2 digits. So 2 digits, this cage here cannot contain a 5 because we would have nothing to put in this cage here. Is this one as a 5. So we can cross out the 5 here, and if we're crossing that out, then we can cross out the corresponding 1 up here. That leaves us with just 3 candidate numbers, the 2, 4, the 5 up here, and the 1, the 2, and the 4 down here. So although we haven't solved either of those cells by looking at these, we have worked out 3 candidate numbers. We could look at the complements of these 3 numbers and work out the candidate numbers for this cell here as well if we wanted to. Although to be fair, it's only a 2-cell 5-sum cage, so that would be easy to do anyway, but you get the idea. So that's looking at multiple outies. We can do the same with multiple innies, and indeed we could have done the same thing the other way around by taking these 2 blocks together, and these 2 cells would have become multiple innies, would have given us the same result. There's another way we can use the 45 rule, slightly more complicated, and that is to combine an innie and an outie. To do that, we're going to look at these 2 blocks, which have an innie up here and an outie down here. Although we could just solve these individually with an innie there and an outie there, but this is for the purposes of the demonstration. But to start with, we add up the target numbers of all the cages that originate within those 2 blocks, which is all of these numbers here, and doing so gives us a total of 95. Because these 2 blocks be tied up to 90, given the 45 rule, 2 blocks of 45 each, we are 5 over, and that tells us that the difference between what we put in the innie cell and what we put in the outie cell needs to be 5. So for example, if we made our innie cell 4, remember this cell was not part of our original calculation. That means that our 95 is now 99, so we're 9 over and above where we need to be, so we would have to put a 9 down here to reduce our total sum back down to the required 90. And 4 and 9 are 5 apart. Now that doesn't allow us to solve these cells, but it does allow us to reduce the possible candidate numbers. This cage with the outie has a target of 11. The largest number we can put in there is a 9, which, as we just said, if we acquire that, we put a 4 in this innie cell. If we put an 8 in here, we would have to put a 3 up here. If we put a 7 in here, we'd have a 2 there. And if we put a 6 here, that would be a 1 up here. We can't go any further than that because we haven't got any more numbers that are 5 digits apart. But we can go a bit further than that because we can look at this 12 cage up here, and we can't use the 1 or the 2 in the 12 cage because we don't have big enough numbers that we could put in the other cell. So in fact, we can eliminate the 1 and the 2 from this cell. Only the 3 and the 4 have added options. So if we're eliminating the 1 and the 2 down there, and we can eliminate the 6 and the 7, down here. So although we haven't solved either of these cells, we have got them down to just 2 candidates numbers there and there. And of course, we could then work out the complements to put the candidate numbers into the other cells as well. And one other thing that I want to mention is cage fitting. And to come back and just look at this one. This is where we started with our first innie. That was this cell here, wasn't it? And we worked out that that contained 3. Now, that doesn't enable us to solve the rest of that cage, but what we can do is split that cage in similar the way we did with the multiple outies. The 17 cage, we can now subtract 3 from that, making it a 14 cage, which has a fairly limited number of possible digits. It's not a brilliant example of cage fitting, but in some puzzles you will find that you can maybe not solve an innie or an outie, particularly in the case of square cages. You may be able to split a cage into 2 and reduce that into 2 separate cages. So splitting cages is another valid strategy with the 45 rule. So there you go, that's the 45 rule. All our examples here have been based on blocks. As I say, in other puzzles, you may well find that you can use a row like this, and you may just have an outie here. We don't, because we got 2 outies, but it's a double outies. We could look at that. We could do the same thing with columns. There's all sorts of ways of chopping up a puzzle, and that's part of the fun and the challenge of Killer Sudoku, is to look at different ways of chopping it up into blocks of 45 or multiple blocks of 45, and using arithmetic to figure out the contents of cells or the difference between innie and outie cells. It's a good technique, and it's certainly completely necessary in some puzzles to solve them. Easy level puzzles, you made it away with just using limited sums and so on. But in most Killer Sudoku puzzles, the 45 technique is absolutely necessary. In the next and final part of this series, we're going to work through this whole puzzle from start to finish and solve the whole thing together. In the meantime, as I say, if you want to try this one yourself, you could download the Killer Sudoku Challenge Pack from the site. There's a link in the description. There's 7 puzzles, and they get progressively harder. And you'll find some written tips and information about the 45 rule and other techniques in that pack as well, along with our cheat sheet.